Morning, everyone. My name is Jim Kim. I am an assistant professor of anatomy at Lincoln Memorial University. I would like to take this as an opportunity to thank you for having me as one of the keynote speakers for this important conference. I feel very honored to be here today. Today, I'm going to talk a little bit about how we're going to globalize forensic anthropological standards for South Korea, and we're going to see how we develop age of death estimation specifically as an example. Okay, so at this point, we're all too familiar that forensic anthropologists usually start off by building a biological profile in order to answer the very question of who this individual is based on unknown skeletal remains. So a biological profile is made up of these various components, including sex of an individual, age of death, ancestry, stature or height, or even we look at the signatures of pathology or disease or any antemortem, postmortem, perimortem trauma based on the skeletal remains. And among these parameters, age of death estimation is especially important because it helps us narrow down missing victims' cases in order to facilitate positive identification in case of mass fatality incidents such as train, plane crash, or natural disaster. And it also helps us to repatriate those soldiers killed in action. And this photo shows us the remains of Korean soldier who died during the Korean War, being returned to the Korean government and back to their family members after being analyzed in the Central Forensic Laboratory in Hawaii. Okay, so then how do we exactly do age of death estimation? Well, it depends on whether or not we are looking at subadult or adult. For subadult, since the skeleton is still growing, we look at the developmental changes throughout the skeleton. But once the skeleton hits the full maturation, which usually happens around 18 or 10 years of age, then we look for degenerative changes throughout the skeleton. In terms of age indicators that we can use, there are a number of skeletal elements that we can use for age estimation, including the cranial sutures, the dentition, ribs, and those two pelvic joints, which are the most favored ones. So those include the auricular surface of the ilium and the pubic symphysis. We can also see the structural change of the trabecular bone and the proximal femur and humerus. And we can also do microscopic analysis by counting the number of osteons in the cortical bones. So those are the options that we have. But then for this specific presentation, we're going to focus on degenerative changes of the adult, so adult age of death estimation, specifically based on macroscopic observation-based approach. So how do we exactly do age of death estimation? Well, we usually divide a lifelong change of an age indicator into a series of ordinal categorical scores. So here I'm showing the Suture-Brooks method of the pubic symphysis, which divides age-related changes of the pubic symphysis into 6 different stages. So on the left side, we can see the pubic symphysis of a young individual, and as we get old, so on the right side, it shows the pubic symphysis of an old individual. And for each phase or each stage, we have a set of skeletal traits that we're expected to observe. So those traits include specific topography, texture, and completeness of the symphysial face. And based on those suite of skeletal traits, we assign an unknown skeletal element or the pubic symphysis into a single phase or 2. And for each phase, we get a point age estimate and also an age range. So those are our final age estimates. Now, there is a myriad of various factors that influence the natural skeletal aging process, including the genetic predisposition, nutritional status of one individual, and activity level, and etc. But one of the most influential variables for aging of the skeleton is known to be one's ancestry. So in other words, individuals with different ancestral groups or individuals with different ancestral affiliations are presumed to have different rates and patterns of skeletal aging. And so in a more technical terminology, we call that process as population variation or population specificity in skeletal aging process. And it has been a very active area of research since the early 1900s in the biological and pathology literature. So according to the best practice guidelines outlined by Scientific Working Group for Forensic Anthropology in the United States, it's like an overseeing organization to promote best practices in forensic science case analysis. So according to this guideline, they acknowledge that there is population or ancestry specific variation in relation to skeletal aging, and therefore it is recommended to use population specific standards whenever possible. In the case when population specific standards is not available, then it is recommended to use a more inclusive method that can accommodate more various populations. But do we practice according to this best practice guidelines? Well, that's whole another story. So even though we have been placing much emphasis on developing and using population specific methods, most age estimation methods are developed on European American populations representing 19th or 20th century American. And so we still have a lack of understanding of skeletal aging variation in other populations, for instance, for Asians. And there has been almost a zero emphasis on developing more inclusive methods to accommodate more diverse populations. So especially in age estimation literature, there is a serious underrepresentation of Asian population, which I think is quite unfortunate given the fact that Asia is the most populated continent that houses 60% of the world population. So if we assume that there is such thing as population variation or population specificity in skeletal aging process, then by not studying enough the Asian population, that we are potentially missing out those 60% of the world variation. And nationally in the United States, there has been a growing awareness of more studying Asian populations, especially for forensic settings, because Asians are the fastest growing ancestry or ethnic group among any others in the United States. Now, coming back to the case of South Korea, because there are I shouldn't say none, but there is a lack of method that accommodates Korean population, specific to Korean population. And therefore, whenever we confront with unknown skeletal remains excavated or discovered in the Korean peninsula, then we have to constantly deal with this dilemma as to what method that we're going to use in order to analyze those unknown skeletal remains from South Korea, for example. So in order to mitigate this issue, we formed a multidisciplinary team that involves multiple institutions, and it is a multi-year, a huge project participated by a number of leading experts in forensic anthropology, forensic sciences in general, and also the engineering department. So our goal is to essentially to develop forensic standards, so for age estimation specifically in this case, that has limited subjective interpretation based on sound science, so that we can clearly and proactively communicate any weaknesses, limitations, and strengths of the methods that we developed based on South Korean population. So as the first steps to globalize the Korea's forensic standards, we have been building a large-scale reference skeletal samples representing Korean population. And we have been quantifying and modeling age-related change of age indicators with more sophisticated statistical analysis. and we seek to develop age estimation method by using robust computing algorithms. So to just give you an idea how we have been doing this, so as a first step of building the forensic standards, we have been establishing reference skeletal samples of the Korean population. And for this part of the project, National Forensic Science has been a rock star. They have been building this large-scale post-mortem full-body CT scans of modern Koreans. So those are forensic case victims of the South Korea. And so, so far we have accumulated a little less than 250 individuals, including Korean males and females, age ranging from 20 years all the way up to 89 years. And on the right side shows a snapshot of the age distribution or the sample distribution of the CT scan data. So essentially for age estimation, we want to start with a uniform distribution in order to minimize any sampling bias and to ensure that all age groups are equally represented. So that's part of my goal, part of our goal. Secondly, we have been quantifying age-related, the shape change of the major age indicators, including the pubic symphysis and auricular surface. So these two have been the active area of research as of now, and in the near future, we're going to expand the skeletal elements to the sternal end of the ribs, clavicles, and many other elements distributed throughout the skeleton. So this slide shows you age-related change of Korean female pubic symphysis. So on the left side, it shows you very young pubic symphysis at the age of 23. As we can see here, it shows very clear pattern of the ridge and furrow system, which is a very characteristic pattern of a young individual. And there is a lack of delimitation of upper and lower extremities in absence of rim formation, which I would confidently assign this individual into stage 1. In the middle, the picture, it shows the pubic symphysis of an individual at the age of 44. And as we can see here, it shows a full completion of symphysial face, characterized by the formation of the rim around the pubic symphysis and clear delimitation in the upper and lower extremity. And this can be a characteristic of stage 5. Now, as we move on to upper age range, so this is a pubic symphysis of 88 years old female. We can see that the symphysis start degenerating. So we can see lots of extra bone growth along the ventral side of the symphysis, breakdown of the rim, and lots of irregularity on symphysial surface, including the depression and pitting. So then at this point, I would be confidently assign this pubic symphysis as onto stage 6. So based on this ordinate categorical score, we have been using transition analysis, or more specifically cumulative probability regression analysis. So this part of analysis essentially tells us the speed of aging for the Korean population. So the reason why this analysis is called the transition analysis is that the cumulative probit, or it can be also logit regression analysis, tells us at what age that a certain age indicator transition from stage 1 to stage 2. So that's where the name transition analysis comes from. And particularly the cumulative probit regression has been favored in the field as a more sophisticated way of modeling age-related change of an age indicator. It can be used, of course, for various other age indicators other than pubic symphysis. And then once we get those transition analysis part done, then we are going to utilize the parameters by combining it with Bayes' theorem as the inverse function to get final age estimates. So just to give you a quick outline how Bayes' theorem works here to give us age estimation. So then the final, the ultimate goal for us here will be this. We're interested in knowing the probability of a known skeleton is at a certain age given the skeletal traits that we observe. In Bayes' term, this is called the posterior probability. However, what we get based on the skeletal data, that is the CT scan data, is the probability of observing skeletal characteristic, observing a certain skeletal traits given a certain age, which is in Bayesian terminology called likelihood. So in order to go from likelihood to posterior probability, we need one more the probability. But just to reiterate, so we obtain the likelihood from the cumulative probit regression, as I explained in the previous slide. And so in order to go to posterior probability, which is our ultimate goal, we need one more probability, that is the probability of death at random at a certain age, or the risk of death for the entire population before we make any observations on the skeleton. This is called the prior probability. And the prior probability can come from a number of different sources. We can utilize the documented age of death that comes with the CT scan data, or we can incorporate population mortality data published for specific for Korean population. And so the reason why we want to use Bayesian inference in exchange of other statistical approach is that the outcome of the Bayesian inference is probabilistic in nature that formally quantifies any uncertainty in final age estimates. So in other words, because of the quantification of uncertainty in the estimates or estimation, it has better court admissibility. And it also minimizes this unwanted phenomena called age mimicry that essentially imposes the age at death structure of the reference skeletal samples onto the age at death estimates of the unknown skeletal remains that we're interested in analyzing. So in other words, because of these two main reasons, the Bayesian inference in using Bayes' theorem has been championed, at least in the United States, as an ideal way of developing age of death estimation. And thus, Bayes' theorem provides a convenient means to combine biological data, which is the data or information that you get from the skeletal remains, with the written records of death, so that you can combine those two in order to obtain more statistically sound and realistic, accurate age of death estimates. So then this slide kind of reinforces my previous point. So as for obtaining informed prior for Korean populations, we have a number of different options. We can either use forensic victim death data, so that is essentially the age of death data that comes with the CT scans, or we can use Korean population mortality data, specifically from 2018. So we can use the mortality data that overlaps with the period for the CT scan data. And on the right side, it shows kind of preliminary research findings. So the forensic mortality, it compares the forensic mortality, which is the bottom curve, in the upper curve. So these two are Gompert's hazard model curves. So the upper curves indicates the Korean female mortality in 2018. And as you can see here, these two priors are significantly different. So we might need to play around a little bit between these two informed priors to figure out which one produces more accurate and reliable age estimates for Korean populations. And if we don't want any influence of those from the informed prior, then we can also opt for using a uniform prior or uninformed prior, so that we rely on mostly the information that we get from the skeletal data. All right, so then expected outcomes from the current project. So at the end of this project, hopefully it's going to be the very first to establish a Korean specific age estimation standards based on robust statistical analysis. And then we're going to build a very large scale CT scan data that can further foster future research using different age indicators and also newer, more innovative quantification techniques. And then the results of this study can serve as a baseline knowledge to do comparative analysis that place the Korean populations with other populations so that we get better understanding in how population variation progresses in terms of skeletal aging. And the results of the project can also serve as a baseline to develop more inclusive standards to accommodate more diverse populations. All right, so in future, I know I talked a lot about the observation-based age estimation, but in near future, we're going to do some more computational-heavy, computational way of quantifying the shape, topography, and the overall surface change of the pubic symphysis and other age indicators as well. And by using the results of the current research, we can compare how the skeletal aging of the Korean population is different from other Asian populations. So here it shows the result of the research that I did, that I recently did last year. So I compare the speed of aging of the pubic symphysis between Thai males and Japanese males based on the cumulative probability analysis. And the results showed that those two populations didn't have significantly different schedule of aging, at least in the pubic symphysis, which further suggests that those two populations can be combined together to build a more broader Asian specific age estimation methods. And then again, this is another fun research or analysis that I did in the past. So essentially, I compared the pooled Asian parameters, age estimation parameters. So here, pooled Asian means I pooled Japanese and Thai males, and I compared those age estimation parameters with American parameters. And lo and behold, the schedule of aging, especially in the pubic symphysis, wasn't that different between these two populations, which then further indicates a possibility of building a more inclusive, more global age of death estimation standards by incorporating both Asian and American populations. Okay, finally, final point that I'm trying to make. So why is it so important to develop and place more emphasis on inclusive and global age of death estimation, even so for Korean population? So South Korea has been rapidly becoming a multicultural and multi-ethnic community. So here, And this slide, this little blurb, is what I got out of a recent news article. I think it was published by Yonhap News in early 2020, so this year. And it says that 2.5 million internationals now reside in South Korea. And that is 5% of the entire population. And I think that is definitely not a negligible number. And so the majority of those internationals include Chinese individual, the largest group, followed by Vietnamese, Thais, Americans, Japanese, Russians, Cambodians. The list goes on and on and on. And the number even goes up if we include refugees and those undocumented migrants. And as a backup of this claim, I got this handy dandy summary statistics from Korean Statistical Information Service. So this is 2019 census data for South Korea. And this graph shows a breakdown of those foreign nationals based on their nationalities and ethnic groups. So what I'm trying to convey in this final slide is that when we talk about Korea specific or Korean population specific forensic standards, that doesn't necessarily mean that those standards should only accommodate individuals of East Asian descent, right? Now the modern Korean demographic trend requires us to have a flexibility to accommodate these various populations who now are the members of the Korean society. So as a first step to globalizing the standards, the forensic standards of South Korea, I think first we need to follow those the best practice guidelines outlined by the international forensic science communities. But at the same time, we should be able to accommodate the fastly growing multi-ethnic communities in South Korea on top of those basic methods specifically aimed for the individuals of the Korean descent. So I don't know, maybe in the down the road, that concept that South Koreans really like to have this pure-blooded South Korean, it might not hold much place in terms of method development and in terms of Korean-specific standards. So given this trend, we are expecting to see a growing number of forensic cases involving these various communities and ethnic groups. So that's why I'm trying to place much emphasis on developing inclusive methods that speaks to the global standards of forensic science. Okay, that's all I had for today. Thank you so much for your attention. If you have any questions, please feel free to email me. This is my university email. And thank you so much again for having me at this important meeting. I hope it was more of an in-person thing, but I understand because of the COVID-19, we have some limitations. Thank you, and I hope you enjoy the rest of the conference.